Welcome to the Ricci Flow Nutrition Podcast. My name is Cameron Borg. On this episode, I had the pleasure of speaking with Scott Zimmerman. Scott is an expert in optics and has focused his attention on quantifying the health effects of natural sunlight. With over 35 years of experience in the industry, Scott has unparalleled knowledge about how light interacts with systems. His innovations and inventions have been used successfully in a wide range of military and commercial products that include night vision displays, liquid crystal display backlighting designs, and lighting fixtures. More recently, he has been working closely with world-renowned researchers in the field of biology, looking closely at the relationship between natural light rich in near-infrared, melatonin, and cortisol. His publications are alongside Professor Russel Reiter, the world's expert in melatonin. Scott's insights are profound, and they're changing the way we perceive our relationship with light and are shedding a little bit of light on why we are yet to get a grip on the diseases of modern life. Scott has also started a company, NIRA, and seeks to integrate the best of LED technology and the best of incandescent technology to make light bulbs that are safe and provide much needed near-infrared wavelengths absent in modern fixtures. I learnt so much from Scott in this conversation, and I really look up to him as he's asking all the right questions, and I really appreciate all the work that he's doing. So with all that being said, I really hope you enjoy the episode. Thanks for coming to speak with me, Scott. I really appreciate it. I mean, the work that you've been doing, I think is going to be very, very important as far as our understanding of melatonin and the way that light impacts our health is concerned. So, I mean, I want to know what your background is and how you managed to get tangled up in biology and looking at optics in the human body.
Yeah, well, my background is I'm basically a mechanical engineer that started to get to work in optics. I was doing a lot of aerospace stuff, night vision work, things of that nature, displays. And I guess I'd say one thing I'm probably pretty good at is inventing. I was brought into one of the research centers for Honeywell and Allied Signal quite a while back. Got to work with 350 PhDs. I have 85 issued patents in various areas. And I worked for big companies for a while, and I said, I want to do something on my own. I started a couple of companies trying to lighting areas. But at the heart of things is I love to model what's going on optically. And I started looking at modeling the eye and the brain, the fetus, and all this other stuff. And what you start to see is that the body is assuming that it is exposed to something that's the entire solar spectrum, not just a little slice of it. And once you start looking at that, you start to see these amazing optical effects, especially in the near infrared, because as you may know, there's a biological windows, in other words, regions of the solar spectrum where it penetrates deep into the body. And we're talking about easily into an inch into the body. And the more I started looking at how light penetrates and moves around the body, first off, I guess I should say, anybody who doesn't believe that light can penetrate into the body inches should just take their finger, put it over their cell phone flashlight in a dark room, and you'll see how it just glows. And it's this amazing effect where in the near infrared, when the absorption gets low enough and the scatter gets low enough, that you start to get these kind of volumetric diffusion that goes on. And it's really the body's way to actually extract or use or collect and localize energy in very specific places. In particular, in your blood vessels, in your retina, in the deep fissures in your brain, light guides down into the fissures. And you're kind of sitting there and you're looking at this and you're saying, what's it all doing? And that's where I stumbled into the world of biology. And it's a very difficult place to be when you're an optics guy. But thanks to people like Russ and I started out, I actually talked to Mike Hamlin, who I think you've had on, and other people like that. And, like I say, it just to me, I was approaching it, I believe, from a much different position, where I was an optics guy. I was just looking at where the photons were going, and then when you look at that, and you notice that they're localized in certain ways at certain wavelength bands, then you start looking in the literature and you start to see that, hey, Hamlin's over here doing red light therapy at these wavelengths because, and you can start to see that, the body is set up based on the assumption that it's being exposed, like I say, from 250 clear out to over 4,000 nanometers. And the thing that gets me is that the lighting industry and virtually everything we're doing on energy savings has the consequence, because all of a sudden now we're eliminating huge portions of the solar spectrum. And this is going to be the first generation that's really been the case. And I keep on saying, and people kind of poo-poo it, but we are going through the largest reduction in solar exposure in the history of human race. And unfortunately, there wasn't much in the way of science that went into making that decision. It was driven by lumens per watt, energy savings. The windows on our buildings are all trying to kick out the UV and the near infrared. I'm not saying they're not good reasons. They're good reasons, but there's always an unintended consequence when you start doing things like that. And here now, lately, what we've been doing is trying to, with Russ's help and Deborah Burnett and a few others, we're starting to combine the optics with the hormone situation. First, it was with melatonin, which I did the original paper with Russ on.
Yep.
But now we're kind of moving into the realm of it's cortisol and melatonin and the ratios of those two. And what you start seeing is you start to see why do people commit suicide more likely in the morning? Well, when you look at the cortisol, the melatonin ratios, why do you have sundowning? You look at those ratios, you start to see why. And I think that's what I'd say is what I'm focused on now, is trying to give the reason, a mechanistic approach to what's going on. Everybody runs studies trying to figure out, if I give melatonin at this time or all these other things, but I've been more focused on trying to do the mechanistic, what's the actual mechanism, because once you understand the mechanism, it's kind of like asking the right question, type thing.
Yeah.
So,
yeah. And, I guess the starting point for all this would be, we evolved for millions of years in the constant influence of solar radiation, which is predominantly, the longer wavelengths, the near infrared, the infrared. And it makes a lot of sense that our body would have gone to, huge lengths to use and utilize all of these wavelengths to the best of its capacity, for a variety of different reasons. And like you said, we have experienced in a relatively short space of time, an enormous elimination of these wavelengths. And it's unfortunate because we can't see them, so it's not obvious that we're missing anything. So you get these chronic disease epidemics, and no one really knows why. There's a lot of different things that go into it, but I think the light story is probably at the center of it. I know you're aware of the work being done at University College London with Glenn Jeffrey's group, looking at, I know you've quoted one of his papers looking at people with macular degeneration being halted with the use of near-infrared light. So, there's more of a discussion now about the importance of these wavelengths. And, hopefully that discussion can continue to pick up. When did you first start to speak about this with Russ? And, what were his first impressions when you came to him with your perspectives?
Well, I mean, you have to give Russ credit. I mean, Russ is, he has 100,000 citations, but one of the things he does is he tries to pull in people with different perspectives into what he's been doing. Even though he is focused on melatonin, he was very encouraging. Like I say, I had never even written a paper.
Yeah.
I mean, it was it was extremely patient with me trying to figure out how to even do a reference in a paper, and because to me, I'm an engineer. I'm working on optics and filing patents and things of that nature. Wasn't into writing research papers. And what was interesting was a little bit of a backstory. When Russ and I first started working on this, I had approached the lighting community, and I talked to Hamlin, and I tried to get the lighting community and Hamlin together, and that they didn't want to talk to each other right at that time. And Russ and I had started talking, and we wrote a paper, and I was actually requested to write a paper by the IES 4 years ago, 3 to 4 years ago. And unfortunately, they didn't like what I wrote, and they wouldn't publish it. So we ended up having to go publish in some medical journals, and which was actually a great thing in a lot of ways. And because I felt like it, had a little bit better peer review and all that kind of stuff. But when we first got started, it was just the idea of combining the optics with what the circadian things that Russ have been doing. And he really has been the champion of the extra pineal, the fact that melatonin is produced actually mostly outside the pineal gland. And I think now at this point, it's pretty much, while Russ would say, we haven't absolutely proven it, it's pretty much a given that, you go out and you go sit yourself down under in near infrared whole body exposure thing, you're going to fall asleep. There's a reason you're going to fall asleep. You're kicking your melatonin through the roof.
Yeah.
The same thing happens when you go out and exercise. And that was really the latest, or some of the later papers. We started looking at, getting the data. And what's amazing is there's this huge expansion coming, or new technology coming in the biosensor world. And when you start looking at what happens with the hormone levels in real time, because bear in mind, anything that's out there that's associated with circadian is not really a real-time measurement. They go and they take somebody, they sit them down in the dark, they lay them out, they don't let them eat, they don't let them do all this stuff, and then they measure their the melatonin levels as it changes, and cortisol levels. The minute they have to do that, because the minute you actually start doing something, exercise, eating, going out in the sunlight, all those hormone levels are shifting, and they don't behave the same way. And, that was there's only really about 4 papers in the entire world right now where they actually are trying to measure it during something like exercise, during, being in sunlight. And it was very hard to find real data that was what I'd call during a stressor. The reactive oxygen species are kicking up. The mitochondria are starting to push out all this melatonin. And one of the best papers was by Theron and followed up by Zhu, where they started to show that in sweat and in plasma, you could actually measure these transient spikes. You start doing exercise, you're on a stair stepper or whatever. Your cortisol and your melatonin both go up together. They don't go up in different times, they go up together. And then what happens is the melatonin appears to actually start to affect the ACTH levels in the brain and starts to cause the cortisol, because the reality is everybody needs cortisol to react, but bad cortisol running rampant is a really bad thing to happen.
Yeah.
And so the body has these other hormones coming in that are suppressing the cortisol levels in real time. And so what you end up with is you start out with a rapid increase in cortisol and in melatonin, but then as Gao showed in his sweat measurements, he has some really great papers, that about 10 to 20 minutes into the exercise, the cortisol level starts to drop off, but the melatonin doesn't. And so you get this little bit of excess. So the body seems to be designed to essentially finish a particular stressor with an excess of melatonin, which is the body's best antioxidant. And so you get this common sensation of of sleepiness, I guess is what I'd say, after you do certain stressors.
Yep.
And it's really just related to how your hormones are being shifted. Now, it doesn't discount anything that's going on with circadian. Circadian still does its stuff and all that. But it's kind of like most of the data is only really applicable to somebody who's bedridden.
Mm.
You know, the minute you or I go out and do something, all of a sudden you have this transient, and these numbers are huge. They're 4 or 5 times the levels that we would typically see at night in the plasma. But it's really hard to measure, because the reality is you need some kind of a major stressor to get to the point that the mitochondria, which has a huge advantage in that there's 10 to the 17th of them in your body, but they have to all be generating enough melatonin to actually feed back into the plasma or through the interstitial fluids to get to the point that you can measure it in the plasma. So that's why most of these people that are measuring it, they're not really measuring the total melatonin or the total cortisol, because it's actually intercellular, and the muscle cells are responding by generating enough melatonin to deal with the reactive oxygen species that they are putting out. So that's I guess that's a roundabout answer to your question. but it's to me, it's just absolutely fascinating how the body is capable of doing, has all these different systems that are running. And and then from an optics standpoint, it's just overwhelming or humbling to see how the body takes advantage of the different parts of the spectrum. And the unfortunate thing is that the people that are focused in on the energy savings of DOE and people like that really haven't taken this other part into account or consideration. And I think that COVID proved beyond a shadow of a doubt that if the consequence of saving a little energy is people get sick more, there's no energy savings. So that's my concern.
Yeah, well, I want to focus in on that first paper that I was aware of. I think it was 2019, Melatonin and the Optics of the Human Body. One of, if not my favorite papers. I know a few doctor friends of mine also say it's their favorite paper. And there's a few amazing graphs in there that talk about the folding of the brain and how those folds are actually somewhat designed in a way to ferry the light as far into the brain as possible. I'm not sure if that's exactly what you meant. Maybe you can help me clarify that. But first of all, people might be a bit weirded out by thinking that light makes it through the skull. So what's going on there?
Well, if you actually look at it, and I think I don't know if you've ever seen any of Roger Seaholt's videos. He has a couple of illustrations, and then there's a TED Talk where one of the ladies there I could send to you that does an illustration. But in the old days, if they were checking your sinuses out, they would literally take a red light, shine it up through your mouth and out, so they could actually see what kind of occlusion, so they can see through the bone structure.
Yeah.
And it's like I say, it's hard for people to get the idea, but you can literally walk outside now with modern cell phone, and you can put it up against your arm and have the sun coming through your arm and covering up and you can see the red window associated, or the biological window associated with going clear the way through your arm, through the bones and everything.
Yeah.
But there's a big difference optically between absorption and scatter. And what happens is that the absorption coefficient goes down so low, even in bone, that you get the scattering effect, but it's not an absorption. But when people have tried to measure it, most of the people will go and take a lamb's head or whatever, and they'll stick a detector in there and they'll shine a light through it. They're not taking into account that that's not the way it works. In order to measure a volume diffuser, it's a very difficult measurement, because you have to take into account the fact that light is penetrating not only from this one spot, but multiple spots, and it's all additive in its nature. And once you get through the skull, you got what it does is essentially actually a forehead acts like it's a really great filter. And the same thing happens with a woman's skin for the fetus in the womb. is that literally it blocks the ultraviolet and invisible from getting down into the cerebral spinal fluid or into the amniotic fluid. And both of those have peak transmissions at 850 nanometers, well into the near infrared.
Right.
And so what happens in our lighting world, we call that a light guide. Essentially, it has the cerebral spinal fluid is very clear. It doesn't have much scatter. And so it tends to propagate the light down into the fissures of the brain and makes this, amazing ability for the near infrared component to propagate, like I say, propagate down into the fissures. And it's just so amazing when you look at a cross section of brain and you see the gray matter where it is and how it follows those fissures. And I know there's a lot more biology than all that, but from an optics guy standpoint, you kind of look at it and say, duh, yeah, that's what it's supposed to do.
Yeah.
And we use light guides all the time in the lighting industry to propagate light down from one point to another. If you look at ceiling panels that have LEDs on them, the LEDs are on the edges and they're light guiding it down an acrylic or a polycarbonate guide. And then they're having little places where they extract the light. That allows you to get it uniform. And, I just don't believe that there's so many things that the body is doing optically to localize and collect near infrared and put it right where it needs to be, that it's on purpose. I'm sorry. It's not just a happenstance that, and, you look at the mother's womb, how the skin starts as, you go through the pregnancy and eventually the skin starts to stretch. My wife and I were lucky enough to have twins and she had 13 pounds of baby in her. Wow. And, it went translucent. I mean, I could see through her basically. And so it's changing the spectrum. And there's all these indications that is important to how the fetus's eyes develop and other things develop, is it gets introduced to this thing. And I was talking to some of the people in one of the neonatal units, and they were saying how they're starting to figure this out with neonatals, is that everybody was under the assumption that the neonatal baby coming out would want darkness, but actually, and quiet. And so they would literally go and they would cover the neonatal bassinets with towels and things like that to make it darker. But now what they're figuring out is that no, it actually needs light. It needs light to come in and actually synchronize the baby. And so there's all this stuff that we're still trying to figure out. And this was just 10 years ago that people were looking at it this way. So.
Yeah, that's incredible.
Yeah, but the paper was mainly associated with trying to bring together Russell's work on extrapineal melatonin and link it up to what's going on with the near infrared component. And the idea that seems to be the most prevalent is that the reactive oxygen species that's being generated in the mitochondria, melatonin is produced locally intercellular to that particular cell, and only when you get enough reactive oxygen species does enough melatonin get made to actually spill out into the other areas. So,
is the reason near infrared light causes an increase in this mitochondrial melatonin because the near infrared light helps the mitochondria produce energy more efficiently, so that as a result you're getting more reactive oxygen species?
Well, I think it's really complicated, to be quite honest. And you hit on one of the things that came out of the data, because see, what we did with our data was our first work is we combined optical ray tracing with the work on reactive oxygen species or free radical generation in skin.
Yep.
And that data actually came out of the cosmetic industry, of all places. But we were able to then show is that, okay, the near infrared is generating these reactive oxygen species or free radicals all the way deep into the body. And if you make the assumption that there has to be an antioxidant response, of which melatonin is one of the more likely candidates, then it kind of makes sense, and you can try to see that in certain cases you get so much going on that you get an excess, and that seems to be following out of the data as well. So,
Mm.
I think there's a lot of questions as to what the exact reason that melatonin is being created, but I think with this new data coming out of during transient effects during stressors like exercise,
Yep.
it's being generated is the bottom line. If it's not, where's it coming from? Because it's a whole lot of melatonin when you're sitting there pumping iron or something like that.
Yeah, I mean, it's really fascinating to think that I think in one of the papers, um, it's, you're quoted suggesting that pineal melatonin represents only about 5% of, the total pool. And I think in the latest publication, you outline 4 or 5 different places where melatonin is coming from. One of them being the microbiome, which is probably not all that surprising given that mitochondria are ancient bacteria.
Yeah.
It's not surprising that the bacteria that live in our gastrointestinal tract also synthesize melatonin. Um, do you know, did you get any idea while you were working on that paper about what the mitochondrial, sorry, the microbial melatonin might be contributing to?
To be quite honest, you'd have to ask Russ a little bit more about that to be specific. I mean,
Mm.
I try and stay within my lane a little bit.
Well, I will ask you
And
an optics.
I have opinions, but that doesn't mean that they're based on anything great. But
I would love
yeah.
to hear your opinions, even if they don't, pan out to be true.
The other person, Deborah Burnett's been talking about the microbiome for quite a while as well,
Mhm.
and the effect on it. And I think that there's a big difference. Where we're at right now is I'm trying to focus and look at the time in transient responses and time-based approaches. And there's a huge difference between melatonin that you take internally, or take a pill,
Mhm.
and how it releases, even with the time release stuff,
Mhm.
versus what we're getting through the skin, what we're getting through the gut, what we're getting through all these different locations. And the there's quite a time delay that occurs, and you have to take into account the half-life characteristics of the liver and kidney taking stuff out of it. So it's a pretty complex system. So the idea that I think that it's pretty good right now, or pretty good bet right now, that the melatonin is being produced in all all these different areas. The
Yeah.
question is what's the most relevant, and how do we take advantage of it? I personally believe more in sunshine. Russ would probably say he believes in both, but he takes a lot of melatonin.
Yeah.
Yeah, and so I think that's a lot of that's still up for debate and question. But I don't think it's any more a question that the pineal. I make the statement in the paper that to me, the pineal gland and the brain are kind of like the mitochondria and the nucleus, from the standpoint of, I look at it and say, the pineal gland is doing a very important job to provide antioxidant and all kinds of other benefits to the brain, which is 80% active while we're sleeping.
Yeah.
And so it needed, it's almost like I'd say melatonin was selected for a very specific reason for the brain. And the idea that it's not, and now we know that it's being used also for the muscle cells. There's no doubt about that. And, as you say, the microbiome and all these other things. And then where, you have all this amazing effect. One of the things from an optics standpoint is that, when we walk outside, a lot of people will say, well, direct sunlight is X. It's half of it's visible UV and half of it's near infrared. That's really not true. What happens is the minute you walk outside, we are walking vertically. We have hair on the top of our heads. All the surrounding leaves and the trees and the grass are absorbing the visible from the solar spectrum and shifting it and reflecting the near infrared. That causes a huge shift in the amount of near infrared. But if you think about us walking around, in our birthday suits and, we're standing vertically, it's like this amazing collector that is selectively picking up all the near infrared that's coming around us and kind of blocking what's coming direct in. And the same even with your forehead, your eyebrows, there's a lot of reasons that we're built the way we're built. And, no hair in certain areas, hair in other areas. And, it's just that from an optics standpoint, there's this huge effect associated with us being outside in nature. And then now all that's going away because everybody's not spending any time outside. So, and don't get me wrong, I'm not downplaying the fact that people can get UV, get melanoma and things of that nature. It's no doubt that's true. But going the other direction, there's also no doubt that we're affecting a wide range of things, everything from our susceptibility to disease, to neurological effects, to hormonal effects, testosterone levels. All that's being shifted because we're moving inside. And even COVID, I mean, we showed a little bit of work where we showed that the people that were in the South in the air conditioning actually saw an uptick in COVID deaths for the first time in Texas and some of those places that have large amounts of air conditioning. So a lot of things going on and that are affecting our health. And I think it's been underestimated as to how big a consequence it is.
Oh, definitely. I asked Glenn Jeffrey this when I had him on, and he said him and his honorary professor, Bob Fosbury, both said to me that the biggest public health mistake that we've ever made is our lighting industry. They think that's had the biggest. Statement. Yeah, well, that's what I thought. That's a pretty huge statement. And I said to Glenn, what do you hope to do from here? And he said, look, all I want on my tombstone pretty much is that I was a part of them fixing the mistake, getting them to put the invisible wavelengths back in the lights and making lighting safe again. He said that's my goal. So it's clearly a bigger issue than we understand. And
yeah, I just did a couple of write-ups on some work. I found this work by Yakimov. And what he did is he actually measured melanin in the outer 50 microns of the skin and did it at a couple of different skin types. And what's really amazing is what he was able to show is that the melanin levels drop in the outer 50 microns of the skin, drop off significantly. But on top of that, it's oxidized. Now, if you look up what happens, it's very hard to oxidize melanin just with light. That's what it does. It protects us from light. But the minute you add hydrogen peroxide into the mix, photochemically, it drops like a rock. Right. And what it appears to be going on, the outer skin cells are capable, under the exposure, this work by Laura Hudson did, she showed that the combination of UVA, visible, and near infrared caused a 6x increase in the production of hydrogen peroxide in the outer layer of our skin, right where this 50 microns is. So we have this everybody's walking around, they don't know it, but they have this photochemically bleached region, like I say, 50 microns thick, where not only is the melanin reduced, allowing for 285 to come into this region, but also the lipid level is increased. So the cholesterol level is improved. So we have this on the outside of our skin, we have this amazing adaptive photochemically bleached microreactor that I believe explains why we're seeing so much vitamin D problems. Because in order for it to work, you have to be out in the sun, the entire solar spectrum, and you have to be doing that on a consistent basis because it typically takes about 20 days for the cells to move from the basal layer out to the and be sloughed off. And it's independent of your skin color. A person who has very dark skin, it still has this at 285 nanometers has this region that has been photobleached. And it is essentially there's a 5x difference in the optical absorption of melanin at 285 nanometers, depending on whether it's oxidized or not oxidized. So somebody who's sitting inside all the time and they go outside to get their little bit of UVB, they're getting it at a lower rate of production than someone who has been outside on a consistent basis. Even, to me, it's just the most remarkable thing. And this guy proved it. Yakimov proved it using some very sophisticated measurement techniques. And I can send you the paper that I wrote up on it. But it was, to me, it was just absolutely fascinating that, we've got this thing that nobody can see, but it's there. And only at 285 nanometers does it really work. So
that's absolutely fascinating. I didn't know about that. I'm gonna try and summarize that so you can tell me if I've got any of it wrong. So what you're saying is that there is a section of our skin that is susceptible where the melanin is being oxidized by hydrogen peroxide, so that there is this layer that is effectively free of melanin and particularly cholesterol rich, so that UV light can interact with it to generate all of those hormone products. Is that essentially what's going on?
And then you add on to that fact that there's more and more papers that are showing that when we think about hormones, we tend to think about the endocrine system, glands. But now it appears the biggest endocrine is the skin. And there's a number of papers that are out there that are starting to show that de novo, the skin, the outer skin cells are capable of generating cortisol, a number of sex hormones, a number of other dope. Well, I forget which the other ones are, but so you're starting to see that it's not so simple. And you think about it just from a logical standpoint, the skin is taking on so much. The fact that it has to, and I think that's one of the things that comes from the papers, the more recent papers, is that there is no way that you can respond systemically to a number of things that the skin has to deal with. Or you get a cut on your arm. How do you do a systemic response? No, it doesn't. It builds, it takes, and it responds locally in a time scale that is appropriate. And, the same thing holds true for, like I say, this, the cortisol. You got farmer's tan, it's not a systemic response. It's a autocrine paracrine response that is, and the skin is given the right or the capability of generating all these different hormones in response to that effect. Because, like I say, what happens in one part of your body is totally irrelevant. And that's the one thing. If you get a chance, look at Gao's papers on where he's looking at cortisol measurements on sweat. And there's this one paper, one figure that he has where he shows that they took a patient or a participant, stuck one arm in the ice bath, and then he measured the cortisol on the other arm. And it took 10 minutes for the cortisol to go from the one arm all the way over to the other arm.
Wow.
And you could literally see the response from sticking his arm in the bath for 3 minutes, ice bath. And you could see that it took all that time to get through the interstitial fluids, go around, and come over to the arm. But, so there's all these time constants that are going on that you have to take into account to really understand it. And so, I just think it's absolutely fascinating, personally.
And you were saying before that this, just to jump back to what you were speaking about before, this layer of sort of bleached skin where there's little melanin but lots of sterols, lots of cholesterol, that only occurs with chronic exposure, continuous exposure, day in, day out, not intermittent exposure. Is that correct?
Yeah, because what Yakimov showed is that its outer 50 microns, there's a drop off in the melanin levels, and that he noticed based on Raman that most of that was oxidized.
Yep.
And like I say, it's extremely difficult to oxidize melanin using just light. That's what it's designed to do, is to handle high flux of light.
Yep.
But all you have to do is add a little bit of hydrogen peroxide and make it a photochemical bleaching.
Yep.
And everybody knows, you can hydrogen peroxide works great on hair, to bleach it
Absolutely.
out. Yeah.
Yeah.
So the body's been doing it for millions of years. We just didn't know it was there.
And that fits absolutely perfectly with all of the melanoma research that shows that chronic exposure, occupational exposure to sunlight has a protective effect, whereas intermittent exposure to sunlight, the summer holiday where you've been sitting in an office for 6 months, then you go out to the beach and you get a huge amount of UV. And your skin's not prepared for it. Those are the types of exposures that are associated with melanoma, not the continuous ones. So this fits absolutely perfectly with the epidemiology on those types of skin cancers.
Yeah, and it opens up. One of the things I like about doing the optics is it's optics. I mean, we don't have to get into other discussions about all this other stuff. And I did a paper an article with John Luis down there in Miami, and Professor John Luis has done a lot of work on circadian effect within the Black community.
Mm-hmm.
And when you start, it was next to impossible to get optical data on people with dark skin.
Yeah.
It's so concerning. It's so taboo in some ways to have this conversation. Yet when you do it, and we've done one of the few people that actually measured it out to some reasonable levels, and you start to see that there's a real reason. If you're sitting in Chicago and you're not getting out in the sun, or even if you are, you need 3 times the amount of near infrared exposure to generate the same level of stimulation that I do. Conversely, I go down to the equator and hang out there for 6 months and I'm toast,
Yeah.
And the body is amazing in its ability. And that's just looking at everything as homogeneous. In the optical world, there's this other effect. And one of the reasons that when you put your thumb over your little camera light is that you're not just looking at some homogeneous number or a uniform distribution.
Mm-hmm.
Literally, the melanin is put in certain parts of the cell. It's isolated within the cell itself. The interstitial fluid has very low absorption, allows for light guiding and distribution down through it. So, that's not the same as just saying everybody's dyed this color and everybody's dyed that color. And that's not how it's working. And that's why so much light can penetrate so far in the body is that it's not just a standard, Beers-Lambert situation. It's this composite material that has light guiding capabilities even within the interstitial fluids. So it's pretty fascinating, I think.
But, it's incredible. It's absolutely incredible. We're like a light harvesting machine.
Excellent way to put it. I like that.
And
because it really is. We're designed to collect.
Yep. And just to touch on this idea that basically, if you have more melanin, you need more solar exposure, not just because the melanin is preventing you from making, compounds from UV light, but also because melanin is preventing the absorption of the near infrared. Is that correct?
Yeah. And what we did is that I did a series of again was asked to write a paper for one of the cosmetic industries, and because we were using their data, and unfortunately they blocked me from publishing that one as well. But what it was is what we showed is that if you take a look at the optical characteristics, melanoma can kill you. Obviously, it's not a good thing.
Yeah.
But what we've had for the last several decades is basal cell carcinoma increasing, especially among white males.
Yep.
And when you look at it optically, it makes total sense, because what happens is when if you look at the data, and this was data by Zastro, the ESR data, what you find is that half the free radicals being generated in the outer skin are due to UV, but the other half are due to visible.
Yeah.
And in particular, the violets, the blues,
The
and the
blues.
greens. So what was the problem? The problem is that in order to block, and so if you look at it optically, the penetration characteristics of blues and greens allow it to hit basically the basal level. And what happens is that, if you provide somebody with sunscreen,
Yep.
well, socially, you're not allowed to put blackface on somebody. It doesn't go out too well. But the reality is that that only blocks the UV, which is very effective at dealing with the sunburn. But it also convinces somebody, if that sunburn is actually there as a warning signal, you should get out of the sun.
Yeah.
Okay, so now if I'm blocking the part that generates the sunburn, but I've still got the blues, the greens, and the cyans going off, I've just encouraged the public to sit outside exposed to the part that is actually generating the basal cell carcinoma.
Yeah.
And I was sitting there, and one of the researchers said to me, Scott, we know this is true, but melanoma is much more fatal, and 95% of the time we can cure basal. And it's kind of hard to sell makeup that's only available in one shade, black. And so, what do you have? What you now have out of this whole thing is you have a bunch of women that are dark skinned who are literally have makeup that has SPF in them when they don't really need it.
Yeah.
And, it's a difficult problem, I guess I'd say, because you're kind of stuck with this issue that what's socially acceptable is also making people sick, in my opinion. And that's one of the concerns I have with what going forward. So, like I say, from an optics standpoint, it's pretty straightforward. If you block off the UV stuff, you're not going to get a sunburn, but you are going to expose people to this violets, blues, and cyans. And the only way to block those is to actually, and there was a company down in Australia that was actually trying to sell some products out there that had darker skin tones, trying to deal with this issue. So,
yeah, I mean, it's crazy to me that the answer isn't just go in the shade.
Yeah.
But
yeah. Well, I grew up in Kansas, and my grandpa, he had a straw hat on, he had a long cotton sleeve shirt, he had overalls, and when it was time for lunch, we went in the shade.
Yeah.
And that's the thing that gets me. I mean, there's all this work that's out there where they're talking. They start out with ASTM 1.5 direct sunlight, bearing down 1,300 watts per meter Kelvin or meter squared, and that's not what we are designed for. We're designed for sun being in the shade. All most animals know that in the heat of the day, you're not going to just hang out.
Yeah.
You're going to go find a good shade spot. And what I think is just so amazing is that if you look at the reflectivity, have you ever seen near infrared photography?
I have, yeah. I mean, it's absolutely incredible. You told a funny story about them wanting to put it in the phones, but then realizing it was a very bad idea.
Yeah, but I mean, when you take a look at the infrared response, take somebody who's taking pictures in the near infrared, what you'll see is all the trees are white. It's like we're in a snow. The green the wheat fields are all green, are all white, and it's because there's this huge increase in the reflectivity associated. Even dirt has a higher reflectivity in the near infrared than visible. And so what you're literally doing is our surroundings are filtering out the higher energy photons that are capable of doing damage and allowing an excess of near infrared to come into your body. And the majority of it goes straight through your clothes, or a lot of it. So
yeah, and that's the great thing. You don't actually have to be in the sun. You just have to get outside, and you're still getting a lot of the benefits of that natural light. Even though it's not being directly, those photons aren't coming directly into you from the sun. You're still getting all the benefits of the near infrared. So you can go outside, get your UV dose till the point where you need to get out, and then you can get out into the shade. And as long as you're still staying outside, you reap all the benefits of the circadian element, but as well as the I guess the photobiomodulation element as well.
Yeah, and that's the biggest concern I have with the lighting industry is that they took out, if you look at Mark Cooper's work, or where he's talking about vitamin D type production and the effect that we're not looking at, the skin is generating vitamin D without going back to the kidney or the liver. It's generating de novo. That's pretty self-evident. And it is part and parcel of the protection of the skin. But at the same time, you've got the near infrared, which is actually stimulating melatonins and other type of responses and increasing blood flow. There's this great work by Han-Li Liu where she's measured using broadband near infrared spectroscopy in living people, where they literally measure, okay, if I expose near infrared onto the skin of this person, and she's doing it on brain or in the brain area or whatever, you can literally see a marked uptick in the hemoglobin oxygenation levels, the cytochrome Cs in the blood. All these things are shifting, and it's all part of the body's survival technique. And I think that it's underestimated how much is going on in the outer layers of the skin, and how different that is between having it come into your body that way versus a pill. And that's where Russ and I may disagree to some extent. But and I take melatonin too, but like he said, most people around him that know him kind of come to conclusion. But and then what we're starting to look at is that as you get older, it's amazing how quickly our ability to generate melatonin. Now, most of it is measured, looking at pineal numbers and stuff like that. But the bottom line is I think most people would say that the mitochondria is such a key element that defines aging at this point in time.
Yeah.
And, you think about it's losing its ability, telomeres are dropping, things of that nature. But the reality is if you start to lose your ability to generate melatonin in response, or an antioxidant in response to cortisol, you plot the cortisol as a function of age. Cortisol is one of the few hormones that actually increases as we get older. And I believe that it's because melatonin is dropping off, because Campino did a nice paper where he showed that melatonin actually suppresses ACTH, which then depresses cortisol. So this balancing act is going on, obviously. And, why do people move to Florida? Good reason.
Yeah, and obviously this balancing act is being quite disrupted by modern lighting, which is very, very rich in the blue and essentially absent in the longer wavelengths. These 4,000 Kelvin lights are pretty much standard everywhere you go. No near infrared, just complete. I mean, their spectrum is alarming when you look at it, because you got this huge spike, right in the blue range, and that's obviously damaging melatonin, as well as probably causing direct damage to the skin when you're indoors and it's not being buffered by near infrared. So, I was wondering what you thought about people wearing blue blocking glasses with the red lenses that stop the blues and greens coming into the eyes at night. What are your opinions on that?
Well, I mean, my opinion is that it's the ratio that matters. If you're going to be, I walk outside in a lot of blue and a lot of different, that's one thing I kind of disagree with the circadian people personally, in that if I walk outside and I happen to be in Sedona around the red rocks, my spectrum that I'm getting exposed to is entirely different than if I'm walking around, out here in the green, on a walk in the green.
Yeah.
So the idea that you can define some color temperature, or, well, I'm going to get a little more cyan or something like that, I think the problem, in my opinion, the problem is that we've gotten over focused on circadian,
Mm-hmm.
and that most of the circadian issues are really more related to the fact that we've taken away the majority of the solar spectrum from our lives. And therefore, you can start to see these small changes. I mean, I'm not saying you can't see that people have done great work and great data on that, but it's only under very controlled conditions can you see that effect. And once we started seeing these transient response effects where literally cortisol and melatonin were spiking, in 10, 20 minutes and then
Yeah.
falling off in 30, 40 minutes to levels that were much higher than what, like I say, there's not very many people who have measured during transient events. And that melatonin is coming from someplace and cortisol is coming from someplace.
Mm-hmm.
And I think the melanopsin, there's a work by Peter Light up in Alberta, Canada, and he was able to actually measure using patch cell patch cell, actually measure the voltage on individual cells
Mm-hmm.
and then expose them to light. And what he showed clearly is that the skin has more melanopsin in it than our retina does.
Yeah. Right.
And
Yeah.
and so the skin's responding. And how do you isolate that thing? You showed your glasses there. Most of the experiments that have been done on circadian, they stick your whole head inside the integrating sphere. Well, all that skin area has got melanopsin in it just the same as your eye does.
Yeah.
Are you responding to that? Are you waking up? Is cortisol awakening a function of eye response, or is it a function of skin response? There's a lot of questions, I think, that are left there. So, yeah, I mean, people like to wear glasses. I don't have an objection to it. I'm just saying that I think that if you could look at what we do every day when we walk outside, that's not the issue. The issue is that when I walk outside, I got this huge influx of near infrared and UV that are coming into the equation and setting the baselines. And if you don't have that in there, then yeah, you probably should wear glasses. I mean, and that is what we have in our modern society is they came up with this correlated color temperature because the reality is that makes no sense to call something 3000 Kelvin that only emits between 400 and 700 nanometers. 4000 Kelvin is a black body radiator and it has most of its energy in the near infrared, just like the sun does. So, anyway.
I wanted to switch gears and ask you about animal research, which for all intents and purposes is exclusively done in the absence of near infrared light. When lab animals are kept inside, they're kept from the influences of solar radiation. How much do you think this is impacting the results of animal experiments?
Well, there's this really great paper that I found that was where they took spiders and scorpions, and they had little cages for them. One of them they exposed to outdoor light, sunshine. And the other one they exposed to narrowband, high efficiency. This was a fluorescent, but it basically was a narrow spectrum type, full spectrum bulb. And what they did is that unlike other insects, scorpions and spiders have cortisol in them. And what they did is they looked at this as a function of time. And what they found is that whenever they go out and check on the burrow, all these spiders and scorpions would burrow. The ones that were being exposed to the full spectrum lamps they never saw them outside of their burrow, ever. The ones that were exposed to natural light were out all the time. Then they actually killed them and actually measured, and they found much higher levels of cortisol in the spiders and in the scorpions compared to the one that was just under natural sunlight. Just one experiment that shows kind of a thing. But I fundamentally believe that what we're really doing right now is setting up a situation where the body is and insects and other things are actually having elevated levels of stress hormones on a regular basis.
Yeah.
Life now is stressful. I'm not arguing that it's not stressful, and we can have another hour and a half conversation about the food supply. But the reality is, if you look at it just from a pure, everything we do that we've done between the windows glazings we put on, the lights we're using, is stimulating cortisol. Cortisol is responding to, is a circadian, we have an awakening and all this other stuff.
Mm-hmm.
And everything we're doing is also suppressing melatonin, so it's like we've got the cortisol. You have to get up in the morning, you have to go out there, be active. You want to suppress, your fevers until the afternoon by having high cortisol levels. But then eventually the intent is that the melatonin, in my opinion, melatonin is there to suppress the cortisol level down to some point where the brain can do what it has to do at night. We need to sleep. We can't be, flashing ourselves with a bunch of light. And what happens, most of the data where they looked at it, they were always looking at melatonin. Well, they should be looking at cortisol, because cortisol is spiking up while melatonin is being suppressed.
Yeah.
And so I would just argue that, the insects and what I think they're just really stressed out, to be quite honest.
Definitely. Yeah. Yeah, for sure.
Yeah. Okay. Go ahead.
Yeah. Well, I wanted to ask you, since you mentioned you'd spoken to Mike Hamblin, what you think about the current state of photobiomodulation. There's a countless number of companies out there selling panels that have red and near infrared LEDs in them. What are your thoughts on the use of photobiomodulation devices?
Well, I think it's along the same lines of what I think about what's going on with the lighting community and the visible spectrum only.
Mm-hmm.
Is that I believe that what we're seeing, the uptick in red light therapies and near infrared, is really symptomatic of a deficiency in sunlight.
Yep.
And one of the things when I was first working with or talking with Dr. Hamlin is that I noticed that he was running the experiment, and he would do a 20-minute. They really need to focus on a 20 or 30-minute treatment in order to get results, or to make financial success, is what I would say. But I was looking at the levels that they were using in milliwatts per centimeter squared, and if we were in an office that was 500 lux of incandescent,
mm-hmm.
you were basically getting 5 milliwatts per centimeter squared. Maybe it was broadband across a very large range, but it's kind of like, if you're not controlling what happens to that person who walks out of the room after getting a treatment, on whether or not they're going into a fluorescent lit room or an incandescent lit room or going outside, how are you really measuring the benefit, I guess I'd say,
Right.
of the whole thing? And one of the things I did is I started generating these timelines, and I can send you some of them. I'm getting ready to publish it. But you start to see that, okay, I'm going in for 20 minutes to near infrared whole body. You see this huge spike. I have no doubt there's a huge spike in the melatonin. But if you understand that it's like taking a drug. You got the drug, but the body's going to clear it out after whatever you've generated in a certain amount of time.
Yep.
And it looks like this kind of spike with this long tail that runs out.
Mm.
And we're talking about an hour. Within an hour, you're basically back down to baseline. Now, is there long-term benefit? That would seem to be the case. There's the paper by Zhao where they did the Chinese basketball team, and they had regular exposures at night, and they saw an increase over time. And I do believe that it's no different than training or anything else that you do.
Yep.
There can be, but all I'm saying is that, and that's why we do what we do. We're selling lighting systems that basically reintroduce the near infrared back into people's lives, because I believe even at a low, you're better off doing a low level on a continuous basis than doing some kind of a spike. And that's that's my take on what's going on. And but in general, I think that it's probably a fair statement to say that what we're seeing is a response to a deficiency that we self-induced.
Yeah, absolutely. Light deficiency. I think that's really what we're seeing, and it does seem to be beneficial to somewhat replenish what we've lost a little bit. We're indoors sometimes, most of the day on sometimes, so it might be good to use a little bit of extra. But I agree with you. I think chronic low grade exposure, just like we'd have if we were living outdoors. I think that's really what we should be trying to look towards. And at the end of the day, you can't really replace the sun, can you?
Yeah, and I think that it's really dangerous in some ways what we're doing. I mean, people can kind of poo-poo it, but when you look at, there was some work done in the 1980s by Ferrer, where he actually went to people who had schizophrenia and clinical depression, and he measured at midnight their cortisol and melatonin levels. And then he had a control group that he measured the same way. And the melatonin to cortisol ratio was 5 times lower than the control. And, all I guess I'm saying is that, when we start messing around with these hormones, there's all kinds of consequences. And touching base on, it's very hard sometimes to connect things up on a neurological basis versus a physiological basis. People can run some experiments and, oh yeah, I don't, I have more cholesterol. I don't have more cholesterol. But, are you depressed? Are you not depressed? I believe that some people in particular are being put in a position. And, one of the things optically is that not only is it the Black population that's susceptible, but children. One of the things I started doing a lot of this work because my granddaughter was diagnosed with neuroblastoma. And, one of the things that you notice is that there's various therapies out there, hyperthermia type therapies that have an effect where they're using near infrared to augment into various cancer treatments. And then we've spent a lot of time and money associated with trying to model some of those effects, because it seems like cancer cells are more susceptible to certain wavelengths. They absorb more than healthy cells. So, there's a lot of opportunity, I guess I'd say, to supplement or help the medical community do things if we would just accept the fact that, light in particular is doing a lot more in our body, and especially around our hormone, and there's all kinds of, it's pretty well known that a lot of cancers metastasize during the early morning hours. And if you plot the ratio of melatonin to cortisol, it hits a minimum right there, associated with the cortisol coming up and the melatonin from dropping off. And so I'd like to see more work in that area. And, we've been trying to do it as part of what we're doing, but it's very hard because the pharmaceutical people spend a lot of years trying to kind of poo-poo what's going on in photobiomodulation and things of that nature. And they're not really, I think they could be complementary. They don't have to be, either or type thing. I don't believe I'm going to solve anybody's problem with cancer by shining a light on them. But I do believe that, there's plenty of studies out there that show that patients that are next to a window or other things like that are much healthier. And, that's kind of what I think. So.
Yeah, that's fascinating. Speaking about windows, I wanted to ask you a little bit about architecture, and I also want to tie this into your company. I know you're making sort of hybrid light bulbs that have, LED and incandescent properties to give the best of both worlds, I suppose. And basically making the safest and most effective light bulb we can. What are some things we can do in our homes, our offices, to sort of buffer the effects of living an indoor life and trying to give us the best opportunity for light to give us all the health benefits that it can give?
Well, I think part of the problem is that like I say, there's this conflict between lumens per watt, energy efficiency, and
Yeah.
what's going on. And I got an ad for Manderson Window. They were talking about that they're blocking 95% of the UV, and then they're blocking the near infrared. And I'm kind of going, why are you doing this? And,
Yeah.
you know, and, the simplest solution is for everybody. And, I'm getting up. I just celebrated having my 8th grandchild. So I'm getting
Wow.
up in age. And, I just want them to roll me. Tell my kids, I just want to deal with you. At 15 minutes in the morning, 15 minutes at night, just roll me out, leave me there. I won't bother you. Bring me back in. It's that's the first and foremost, and getting outside and enjoying, because there's a lot of other benefits to being outside as well.
Yeah.
But I think that there's a compromise here somewhere where, the architectural, community there was a gentleman who was chief engineer for one of the big architectural glass companies, and I was talking to him. He was retiring, so he's being honest at that point. but his comment is that, well, that I was explaining to him the near infrared, and he said, well, that explains it. And he says that there was a study being done, or they had been offering various kinds of glass, and the further they moved it out into the near infrared, the hospital was seeing better results for their patient. But
Wow.
they hit a wall where they couldn't go any further out, because then they would not meet the energy requirements associated with the government.
Yeah.
And so now what they could do is that they could do what nature does and filter some of the visible energy coming in, and let a little bit do more like a natural approach,
Mm-hmm.
or have something where they have solar tubes or something like that. And that's part of kind of what we've been looking at, is how you can bring it back in a realistic way of understanding. There's none of us that want to have the planet die out. We're not, everybody wants to help the planet. But
Yeah.
at some point in time, you also have to be smart about how you're doing it. You can't just make some bold statement. And I think that that's really what kind of happened with the lighting industry, is they went full hog in, and then you got the circadian stuff going on, and you got all this stuff. And how about we get back to the basics here first, And so what we're trying to do is offer products that, for a kid's room. If you're listening, read with your kid. It has a 3-to-1 near infrared to visible ratio. And then when it's time to go to bed, you click another switch, and it's 10 to 15-to-1 near infrared to one, at a lower level. So it's kind of like campfire coals, for some people. And we've seen some pretty, interesting results with some of the moms. Moms are really good about, wanting to see how the baby can sleep a little bit now.
Yeah.
you know, you know, and is it going to solve everything, or is it going to fix what you did during the day? No, maybe not. But it gives it's a tool.
Yep.
It's another tool that you can do with that type of thing. And then I believe very strongly that, and I could say we can have an hour and a half conversation about that later. The food supply is, in my opinion, very heavily laden with cortisol, and especially baby formulas and things like that. There's this really interesting thing. Have you ever heard of night milk?
Well, yeah, I'm just looking at my paper. I wanted to ask you about night milk, because I've known this for several years, that the time you draw milk, actually, the milk contains a host of different things depending on what type of day it is.
Yeah.
And yeah, not many mothers know that they should write the time down that the milk was pumped, if they use a pump, because that's going to inform the baby about time of day and all of these kinds of things. And yeah, I mean, you can give a little bit more background about the dairy industry knowing full well about all of this.
Yeah, well, I just think it's fascinating that every time we kind of, it's very subtle, the effect, from the standpoint of when you were in the olden times, the baby was with the mother fed the baby when the baby was hungry, and everything was all synchronized up.
Yeah.
And then we started being advanced in our modern society, and all of a sudden, mom has to go to work too, so she's going to pump. And my daughters all would keep track of when they pump, what day it was, and try and cycle it through, but they wouldn't keep track of the time. And then you start looking at dairy farmers, and dairy farmers have known forever that there's such a thing as night milk but what do? They dump it all into the same bin, and it all gets homogenized up, and then there are a couple of companies now, I believe, over in Germany that are starting to offer products where it's, synchronized. What time it was actually, produced, and various things that they're trying to do. But and then I'm not a big fan of formula, to be quite honest. But
Yeah. Yeah.
for those who need to, then they should provide something that takes into account how the mother's timing is. And then you go one step further back and you say, if the mom's got really stressed out and not having good circadian approach, or situation, then you're bound to have colicky babies, and that just gets compounded. I had twins, and when they were angry, they were angry.
Yeah.
Type thing.
Yeah, I mean, it's so fascinating what the body does to, keep track of the time and fluctuate throughout the day to best adjust for, what we need to be doing.
Yeah, and I think it's hard because it's just that, to me, it's a great illustration of how little it takes to mess up something that nature's been doing for millions of years.
Yeah.
Nobody intentionally tried to make babies scream more.
Yeah.
It
Yeah.
just kind of comes out of the what we're doing naturally. So
I wanted to ask you, this might be a little bit of a silly question, but can you differentiate what's the difference between infrared light and heat? I know they're related, but they're not the same thing.
no, and it's kind of the bane of my existence, to be quite honest. Because there's absolutely a watt of near infrared and a watt of blue. If they're, you got a black, so you're just absorbing it. It's a watt is a watt. The problem is that, when you look at it, the body, the absorption spectrum of water in particular, is very strong out into the near infrared, far parts of the infrared. And so, people can feel it. And I do that I kind of take advantage of it to just convince people that there's something going on. We take one of our bulbs and we provide only the visible portion, the LED portion. And then we take a bulb that has our NIRA bulb that has the incandescent and LED combination. And you can literally put your hand, it's 3-to-1 near infrared on one, it's 0-to-1 near infrared on the visible one.
Yep.
You can just literally put your hand above it and you can feel the difference. Well, that's heat, I understand, but what it also is, you're increasing the dilation or the vasodilation, and your blood flow is increasing, the waste removal is increasing, all this stuff. So that's not, you can call it heat, you can call it whatever you want, but it is doing something biologically. We know that for a fact. And when we removed it, we took away those biological effects. So I don't know how to explain it other than to say, you would equate it as being heat, but the reality is it's no different than what's going on in the visible spectrum.
Right.
It's just as far as a watt is a watt.
So if I have a hot shower or a hot bath, am I getting some form of red light, infrared light, near infrared light penetrating into my body?
No, yeah, I mean the body. I mean, if you plot the various black body curves, you got to get pretty hot.
Right.
And it's really been, and it's really been, and it probably answers your question better than anything. Visible light has always been something that we could break up into, and we could see the different bands. There's a blue, there's a green, there's a red, there's a yellow. Well, the same thing happens in the near infrared, but The difference is that the emitters that we have access to are broadband emitters. A filament bulb, a ceramic heater, in your hot shower, the hot water itself. Those are extremely broadband emitters
Right.
because as you get into those longer wavelengths, it tends to extend the bandwidth way out. And, and that's why in some ways I kind of like what they did with the pot growers is that they started talking about photons, counting photons. You have X number of moles of nanomoles of photons per second or whatever. The problem is that everybody does exactly what you just did. They have visible, which there's blue, green, red, and all these different colors, and then there's heat. And that's not true. It's really a function of how the body's using those other wavelengths. And that's what I find really fascinating is when you start looking at how different portions of the spectrum in the near infrared, there's all these different absorption bands for the proteins, for the fats, for the water, all these different absorption bands that are fairly narrow that we have full access to at this point, because there are LEDs out there that can do those different things. And that's why I've been working on this thing with the hypothermia to try and generate a light source that just gets absorbed maximum absorption in the cancer cells versus the healthy cells. And it's not for generating a temperature gradient. It's just for generating higher levels of reactive oxygen species in the cancer cell versus the healthy cells. So
is this like a photodynamic therapy approach?
No, it's the photodynamics guys are mainly focused on trying to introduce some kind of absorber into the body. And the last thing, if you had a cancer kid or grandkid, the last thing you want is another drug going into their body.
Yeah.
So no, what I've been focused mainly on and is trying to look at how can we set up an environment like a vest or something that targets, kind of puts the cancer on its heels a little bit, so that the other treatments because what are cancer drugs doing? They're basically generating free radicals of reactive oxygen species in the hope that they can kill more of the cancer cells than they kill of the other. But for, like I say, anybody who's had cancer kids, the damage done by most of that stuff is pretty horrendous. And but again, it's been really hard because the way the research dollars are spent is allocated. You have to go try something on an adult before you can try it on a child, and then they try and just scale it back down in some ways. It's not really targeted for a child. And that's especially problematic in the optical side because, while 50 to 60% of your cells will see some level of near infrared in a child based on their physical size, you have the same penetration depth. Basically 100% of their cells are interacting with sunlight. So doing things on adults is really not, effective. In my granddaughter's case, she had a tumor on her neck that my daughter found. It was a darkening area. It looked like a bruise, but it tells you that, there's a lot that could maybe be done to to try and do some kind of a continuous low level treatment. As you say, it's kind of like the window sitting in. I believe that the body's got a lot more capability than what we give it credit for.
Absolutely.
So anyway. Yeah.
So tell me a little bit more about NIRA, your company, the bulbs that you're selling.
Well, what it was, what it really is it's pretty simple. You look at LEDs. LEDs are extremely effective at generating visible light, but they're pretty lousy at generating near infrared because they're narrow band, and the near infrared is huge. I mean, you're literally talking going from 700 out to beyond 2,000 nanometers, and that having some effect. Like, pick a wavelength. I mean, that's That's the problem, I think, with a lot of the photobiomodulation is
Yeah.
that it's not just one wavelength. It's
Yeah.
a bunch of them, and we don't know how they all work together. So, but incandescent filaments are lousy at generating visible light, and that's why everybody hates them, or didn't hate them, but that's why we're trying to get rid of them. But the reality is they're extremely efficient at generating near infrared,
Yep.
and 90 some odd percent of the light emitted. But what was really the problem with incandescent is that you had to drive at extremely high temperatures on the filament, the tungsten filaments, in order to get the blues and the greens. So, the reality is that we were overdriving. That's why the life was 2,000 hours. Now,
Yep.
if you take, I don't know, probably in Australia you don't know about it, but we have what's called the Centennial bulb up in Washington or Portland. I'm not sure which,
I do
but
know about it. Yeah.
yeah, yeah. Well, what it is it's just a filament that has been run at very low current density, or relative low temperature or color temperature. Um, and so what we do is we use basically little grain of wheat bulbs. They inherently have about 15 to 20,000 hours by themselves, but we run them at a low voltage because I'm not trying to generate visible light with them. I'm using LEDs to generate that. And that's what ends up being the uh, ability to have the filaments actually have a longer lifetime than the LEDs when you do it
Hmm.
that way.
Yep.
And what's really cool about the whole thing is that the combination, when you put a filament bulb actually has a electrical characteristic that is inverse of what an LED does. So when you put the two of them together like we do, it creates a linear response, which means that I can generate a dimming ratio. I simply change the voltage up and down
Hmm.
to whatever I want between 40, 60 volts and down to zero. So I can do 100,000 to 1 dimming range just by adjusting the voltage. And
Right.
that to me is one of the biggest issues associated with artificial light at night. You know, first and foremost, we need to turn a bunch of lights off. But the second thing is that LEDs, as they're used now, have pretty lousy dimming range. I mean, when you think about going from sunlight down to moonlight is 8 orders of magnitude.
Hmm.
You got to generate a huge dimming range in order to use one source to do that. And, that's typically what I think is the problem with a lot of you can't, you need to be able to tell the neighbor to turn it down a little bit because they really
Hmm.
can't right now. And on top of which, the ones that can turn it down are doing it using pulse width modulation, which, I that's my other pet peeve with the lighting industry is that there's just way too much modulation going on, and
Is
the
that flicker?
display. And yeah, it's flicker, but um, if you actually do a look at if you're outside, we are never exposed to anything that's much faster than about a half a hertz, so a 1 hertz type range.
Hmm.
But what you find is that the lighting industry is defining flicker as being some 30% modulation at a frequency of 1,000 hertz or 10,000 hertz, trying to get. And this was the problem with the fluorescents is that they had to go up to
Yeah.
10,000 hertz. And so all that frequency content is in my opinion, is bad for you. And that was one of the things that, as I told you, Peter Light was actually measuring. What he did was he was literally measuring the cell wall potential on individual cells exposed to light as a function of time. And those cells your eye may not be responding to flicker, but your cells are,
Yep.
because he was able to show that, you have millisecond response times on a cellular level. How bad that affects you, I don't know, but I don't see the reason to have it. That's my
Exactly.
opinion.
Yeah.
And so what we've basically done is we said we have this light source. We have both a DC and AC, but we take advantage of our characteristics to minimize. In the DC, you have zero flicker. In the AC, we have very small amount, and that flicker is what you had when you were sitting in an incandescent lit room in the first place, because the filaments tend to have a lot of thermal inertia and allows it to smooth out some of the flicker effects that other people have. But that's what we're basically selling. And I'm just really trying to get people to understand that there's this whole, I'm not adding something that wasn't there all along. We just took it away temporarily, and it needs to go back.
Yeah.
And it's pretty easy to do. I mean, it's cheap too. I mean, the little filament bulbs and LEDs are very effective working together, and they don't have to, there's almost nothing as far as material. If you look at a standard LED bulb now, all the weight and all the money and all the toxic materials are in the drivers. That's where it's all coming from. And I especially when we get down the road, when we really start to do things like looking at DC grids and microgrids and things of that nature, I think that this is a much better approach to lighting, to switch over to DC and have some kind of a DC to DC converter that's optimized for everything. But the other nice thing is because we use the incandescent filaments, it gives us a power factor of 0.97. So we beat everybody on power factor and a bunch of other stuff, basically. So
that's amazing. Yeah, I did notice you're sold out at the moment of all those bulbs.
Yeah. Well, this is very much a family operated, or friends and family finance thing. So I'm doing the best I can.
Yeah.
I at least got it to the point now that I'm not making them, so you'd be better off than when I was making them. So it's something. It's a work in progress, but we're starting to see it's an interesting problem from a marketing standpoint, because how do you go back to the lighting guys and say, yeah, you know what you were doing, you need to add this in first, and that's a hard nut for them to crack. But finding is that, like I say, the moms and a lot of doctors and nurses, if you get a chance to look at Roger's videos, he's done some really great podcasts on our work, and done a lot more on the answer maybe some of your questions on the medical side.
Yeah,
because he pulls in those other a bunch of other papers that are beyond me, to be quite honest.
right.
So.
Oh, well, it sounds like you've got an incredibly tight grasp on all of this, and really feels like you're leading the way in this conversation. In a lot of ways, the papers that you've been involved in have really shifted my perspective, and I know there's a small but very passionate group of people who have been following those publications, and think that there's a huge potential in where they're headed. So. Thanks for all the work that you're doing. We all really appreciate it.
Well, I think I'd like to do another shout out just with Russell and the other people that have been involved, from the standpoint of, this is not going to get solved. One of the problems is always that we do these silos, and one of the things that I think that I get to say that I do is I'm pretty good at figuring out when we're in a silo, and we need to start pulling other parts in. And I just think that Russ was so helpful to put up with an optical engineer trying to do a biology paper is ridiculous. So
yeah. Oh, look, it's not the first time. I mean, I spoke with Bob Fosbury, who's an astrophysicist working with Glenn Jeffrey in a neurobiology lab, and they figured out a bunch of stuff together that they wouldn't have ever figured out by themselves. So I think it's a similar sort of relationship with you and Russ, where the two of you together are greater than the sum of its parts.
Yeah, well, I think Fosbury's done some great work, and I think that, as you say, there was a negative comment about him being an astrophysicist and not knowing anything about biology. The reality is that unless you're an astrophysicist, you don't understand anything about light. So
No, it's a huge benefit,
Yeah.
and that's the great thing. They could both guide each other and fill in the gaps in each other's knowledge. So it worked out really, really well.
Yeah, and I think, like I say, I mean, we have such a distorted food chain
Yeah.
and lighting situation and all that stuff that's going on. And, some of us have grown up in it, and, I'm no spring chicken and I've got way too many pounds on me. But, part of it is that we're not living in the environment we were designed for.
Yeah.
And it makes it hard. So.
Absolutely. Yeah.
Yeah.
So, I mean, that's why we have to take every opportunity we can to, bring things back to the way they should be.
Yeah, and it's especially disheartening when you see some of the studies that are on ADHD and the cortisol levels that are associated with those.
Yeah.
And when you're sitting and I had a really good friend that he was amazing with the computer, but he had 3 screens going simultaneously, and it basically just fried him out after a while.
Yeah.
And you just want to say, hey, maybe we need to think this through a little bit, or maybe there needs to be, go back a little step back and set some time limits, especially on children,
Yeah.
the myopia epidemic and all this other stuff. There's a lot of things on the side of children's that I think, could be hormonal based issues.
Yeah. Well, I'm really hoping that, conversations like this help spread the word a little bit. And, even if it can just help one person reinstate a good relationship with nature and light, then we've done a good job.
Yeah, I guess. And I question for you. I mean, is ADHD and autism different in Australia than you've seen in like the US? Or
I
I mean,
think
we're up to like 10% or something like that, or are being medicated at this point.
it's very similar from my understanding. We tend to follow the same trends that the US follows. Yeah. So I mean, yeah, we could spend several hours talking about the just those two issues and everything that's involved. But yeah, it's a complex scenario, I think.
Yeah, well, thank you very much for putting on the podcast. I appreciate it.
No, it's my pleasure, and I'm so grateful that you're doing what you're doing, and you took some time out to speak with me. Thank you so much for listening. I really hope you enjoyed this one. If you'd like to support Scott's work, I've left all the links in the description for you to check out if you'd like. If you'd like to support the podcast, you can subscribe on Spotify and YouTube and leave up to a 5-star review on Apple Podcasts. This is a simple no-cost way to support my work and help me reach more listeners. Please feel free to leave comments on my YouTube channel, as I do try to read through as many as I can. I've also put links to all of my social media platforms in the episode notes if you'd like updates about the podcast, information about health, or if you'd just like to reach out to me in general. Thanks again for listening, everyone. Take care.